The year was 1859, and the world was beginning to hum with the low-frequency vibration of the industrial age. In the United States, the drums of civil war were still a distant, muffled beat, and the primary concern of the average American was the expansion of the telegraph, a magical wire that allowed thoughts to travel faster than a galloping horse. But on the morning of September 1st, humanity was about to receive a reminder that no matter how much we master the Earth, we are still small children playing in the backyard of a restless star. This is the story of the Carrington Event, the most powerful solar storm ever recorded, and the day the Victorian world experienced a terrifying preview of the end of the digital age. The man with the glass lens. In the quiet town of Red Hill, England, an amateur astronomer named Richard Carrington was doing what he did every sunny morning. He was sitting in his private observatory, projecting an image of the sun onto a large white screen through a filtered telescope. Carrington was obsessed with sunspots, those dark, bruised-looking patches that occasionally marred the sun's surface. At the time, nobody knew what they were. They were mysteries of the heavens. At exactly 11:18 a.m., as Carrington was sketching a particularly massive cluster of spots, something impossible happened. Within the dark spots, two beads of intense white light suddenly erupted. They grew so bright that they outshone the sun itself. Carrington, thinking his equipment had broken or that a hole had formed in his filter, scrambled to adjust his gear. But the light stayed. For 5 minutes, these twin flares burned with a ferocity that defied explanation. Then, as quickly as they appeared, they vanished. Carrington didn't know it yet, but he had just witnessed a coronal mass ejection, CME, a billion-ton cloud of magnetized plasma and subatomic particles blasted directly toward Earth at 4 million miles per hour. The night the sun refused to set. Usually it takes 2 to 3 days for solar particles to reach Earth. This storm was so powerful it made the trip in just 17.6 hours. On the night of September 1st and the early morning of September 2nd, the world changed. In the mid-latitudes of the United States, places like South Carolina, Cuba, and even Hawaii, the sky didn't turn black, it turned a deep, pulsating blood red. In the Rocky Mountains, the aurora borealis was so bright that gold miners woke up thinking it was dawn. They began cooking breakfast, only to realize with horror that the sun was actually a shimmering green and purple curtain swaying across the entire sky. In Manhattan, crowds gathered on rooftops to watch the celestial fire, some fearing the day of judgment had finally arrived. One witness in Boston wrote that the light was so intense he could read the fine print of a newspaper at midnight just by the glow of the sky. It was beautiful, it was majestic, and for the Victorian world's newest technology, it was a death sentence. The ghost in the wires. While the public stared at the sky, the men and women working the telegraph lines were living a nightmare. The telegraph was the Victorian internet. It relied on batteries to send electrical pulses through copper wires, but the solar storm had slammed into Earth's magnetic field with such force that it induced massive electrical currents directly into the wires themselves. Suddenly, telegraph operators across America found they didn't need batteries. In a famous exchange, an operator in Boston messaged his counterpart in Portland, Maine. "Please cut off your battery entirely for 15 minutes, Boston signaled. "Done," Portland replied, "and yet I am receiving your signal perfectly." For hours, the telegraph system of the United States ran on nothing but the auroral current provided by the sun. But the energy was too much to handle. In many offices, sparks showered from the machines, setting stacks of telegrams on fire. Operators were literally knocked backwards by electric shocks leaping from their keys. In some cases, the wires grew so hot they melted, snapping and falling to the ground like glowing snakes. The sun had reached out and physically touched the heartbeat of human communication. The science of the big one. To understand why this happened, we have to look at the physics that Richard Carrington couldn't have imagined in 1859. The sun is a nuclear furnace, but it is also a magnetic one. Every once in a while, the magnetic field lines on the sun's surface become so twisted and stressed, like a rubber band pulled too tight, that they snap. This reconnection releases the energy of millions of hydrogen bombs. When that energy hits Earth, it compresses our planet's magnetic shield, the magnetosphere. This compression creates a geomagnetic storm. In 1859, the only thing we had that could conduct that energy was the telegraph. If a Carrington-class event happened today, the results would be catastrophic.
Our entire civilization is built on a telegraph that never sleeps. Our power grids, our GPS satellites, our fiber optic cables, and our microchips are all vulnerable to the same induction that set those Boston telegrams on fire. NASA and Lloyd's of London have estimated that a modern Carrington event could cause over $2 trillion in damages in the first year alone, potentially knocking out power grids for months or years as massive transformers, which cannot be easily replaced, melt down simultaneously across the globe. The legacy of 1859. Richard Carrington's discovery changed science forever. Before him, people believed the sun was a static, unchanging ball of fire. He proved that the Earth and the sun are connected in a violent, invisible dance. The 1859 storm eventually faded. The red skies turned back to black, the telegraph operators repaired their burnt desks, and the world went back to its slow terrestrial pace. But the event left a permanent mark on the history of technology. It was the first time humanity realized that our progress has a solar tax. The more we rely on electricity, the more vulnerable we become to the star that gives us life. Today, we have the Deep Space Climate Observatory, DSCOR, satellite sitting between us and the sun, acting as a buoy in the cosmic ocean. It gives us about a 15 to 60-minute warning if a solar storm is coming. But as we look back at that September morning in 1859, we are reminded of a chilling truth. The sun has a temper. And while Carrington was lucky enough to see the spark, we are the ones who have built a world made of tinder.